Have you ever thought of a bot which can run itself? Or a bot which can follow a track or a path provided to it? Or a bot which can also solve a maze? Or a bot which can also take part in a Formula 1 race? In this video tutorial, we will show you how to make a track following robot and solve such interesting tasks. So here we start with the line follower robot without using PID algorithm. That is, we are purely using a digitalized version of a line follower using basic principles which are being used in a line follower robot. So here are the apparatus which we require: an Arduino or the processor which will run the whole process. Here we are using an Arduino Uno, but you can use any other Arduino forms as well. You have a list in the description. You can choose any one from them as per your requirement. I'm not going into much details about the Arduino. I'm going straight forward to the next item which we require. So here we use one motor driver to run the two motors, and it contains an IC L293D. You can see the configuration out here on the right side. You can see that there are two input pins and two output pins on both the sides. Two enable pins also, one on each side to enable the motor. I'm not going to much details about this IC. Yeah, we use a pair of motors. We can use center shaft or side shaft motors, and you can also choose your own wheels according to your choice or requirement. Just make sure that you choose your wheels in such a way that it balances the height. I mean, you cannot choose one wheel of a bigger size and the other with a smaller one, otherwise it would not balance the bot. And also the speed also you can choose of your own choice. Here we are using a 500 rpm one. You can also go for a higher one, that is you can go for 1000 rpm one, or you can also choose 150 rpm one as well. That's always up to you. Now the next thing that we need to balance the robot, that is caster wheel. You can see there is a wheel out here made of steel. It runs along with the two motors. Also it gives a support to the back side of the robot. As you can see, we are using only two motors which will be kept at the front, and the back side will be laid down then if you don't give any support. So it also gives support along with mobile wheel so that the boat can run smoothly along the surface. The next thing which we use are some set of jumper wires, female to male, male to male, or female to female as well, according to your requirement or choice. Now the next thing, or the most important thing which we need here, is the IR sensors. Here you can use a single piece IR or a set of array IR as well. Now the benefit of using IR is that your connection decreases. As you can see here, you have to use only one power pin, and the rest will be the signal power pins from each IR of the array. If I use a single piece of IR, then the circuit will be a bigger one and there will be more wires, so there will be a chaotic situation. So to avoid that, we can use an array of IR. Here we are using an 8 array IR sensor. You can see here there are 3 power pins and 8 analog and 8 digital pins as well. Since we are dealing with the digital part only, we will be using the digital 8 pins only in this tutorial. So let's proceed. Now the enter project depends on the working principle of IR sensor. Now how does IR sensor works? Now this thing is described in another video tutorial. The link is given in the description. You can check the working principle of IR sensors in case you don't know. Now let's proceed to the algorithm for coding of this line follower robot. In the algorithm part, we have first the setup, where we declare all the pins which we use as input or output. And according to my circuit, you can see I've used pin number 12, 13, 7 and 8 as output, and the rest are all input pins. And then we come to the logic part. First of all, we read the values of the sensors. We declare a function read sensors, and where we have variables which are all globally declared, and each variables reads the value of each IR, counting from IR1 to IR8 in the array, and also the extra array which we have used, that is IR9. Now these are the 3 cases that we need to cover. First is moving forward. This can be done by moving the left motor forward as well as the right motor forward. The second case is moving right. This can be done by moving the left motor forward and the right motor backward, and moving left, which can be done similarly by rotating the left motor backward and the right motor forward. You can see I haven't included the backward step because we don't need that case here. We are only concerned with the forward move, right move and left move. Now in the right and left move, you can also do one thing. You can, in case of right move, you can stop the right motor and only move the left motor, and similarly in the left move you can stop the left motor and only move the right motor forward. That's up to you. Okay, so now coming to the coding part, we will see in the circuit that we are using an extra IR sensor and we're placing it in between IR4 and IR5. Now what is the target of this project? The target is to bring the bot to the track whenever it gets, or even it tries to get out of the track. So even if suppose there is a turn, a left or right turn, that means the bot is at present not in the track, and there is a turn, that means you need to bring back the bot in the right route or right track. So how would you know that the bot is on the right position or the right place or on the track? Now the IF4 and IF5 of that array, the sensor array, the 8 array sensor array, and that extra IR which you have used, that is IR9, when these 3 will all be high, at digitally high position, then we come to know that the bot is at the right position or on the track. Whenever this 3 will not glow, that means the bot is not in track. Then we need to search for some other thing. And whenever these three are digitally high, the bot doesn't need to look for any other values, that is any other higher values of the array. It just moves forward if it gets these three higher as digitally high. So aligning the bot to the right track. So what happens, uh, the two motors, though their specifications is same, but still the motors don't run exactly in the same specification. There is a minor error. So what happens, the bot sometimes tries to get out of the track. So it actually doesn't follow the code which we just now discussed, that is value 4, 5 and 9 would be digitally high. So the three values are not digitally high, and there are no turns as well, just because the bot gets out of track, but still there is a forward track. So how can we know that the bot is out of the track, or how can we bring the bot into the track? So coming into the algorithm to align, uh, there can be two cases: the bot going along the left side or the bot going along the right side. Now if it is the first case, that is the bot going along the left side, the sensor reading will be like this, that is the left higher's of the array will all be 0, and the right higher's can either be 1 or either be 0. That's why I've written don't care conditions here. Now, if it finds that the left arrays are 0 and right array is 1, that means it now needs to move rightwards. That means it has bent towards the left, and now it needs to move towards the right. That's why I've given here don't care conditions. That means here one LED, one IR can glow, as well as two IR, and can be three, or it can also happen that four are also glowing at the same time. It depends on the width of the track. And considering similarly the second case, that is the bot is going out along the right side. Now in that case the left IRs would be the dependable factor. It then needs to move along the left so that it comes to the track. Now how to overcome inertia. Now since we are implementing the logic purely in digital manner, the bot will gain some inertia. So whenever there will be a turning point, it may be acute turn or maybe obtuse turn or maybe right turn, be it to left or right, the bot will run out of the track because of inertia. So we need to control that inertia, or rather we need to stop that inertial movement. What we can do is you can use a stop function which will stop all the motors in each cycle of operation, but we need to cut off the inertia, but that will not help using only the stop function. So what we need to do is we need to insert our delay function for 6 to 7 millisecond in one cycle in order to cut off that inertial movement. Now the turning portion. Now there can be two turning directions, that is left or right. Now when to turn, the bot will turn only when the ninth array will be 0. Whenever the ninth array will be 0 and the IR 4 and IR 5 will be 1, then only it will search for a change of direction of the track. That's why we have used the extra array, and this is its significance. Whenever the IR4 and IR5 will be high and IR9 will be low. That means the board now needs to check for a turn. Now if it finds that IR6 to IR8 glows, that means the board now needs to turn right. Or in case if it finds that IR1 to IR3, I mean IR1 to IR3 or IR6 to IR8, I mean to say that any of them can glow or maybe all of them can glow at simultaneously. Now whenever it finds that this set of LEDs glowing, that means it needs to turn around this direction accordingly. Now coming to the priority, now you need to set up in the code the priority order. As I have mentioned, whenever it finds that value 4, 5 and 9, I mean the value of the IR 4, 5 and 9 are high, it will always move forward irrespective of other sensor values. So in this way we need to set the priority. So this is the first priority of the code. Now the second priority is up to the user who will be using it. In case where the bot finds that all the LEDs of the right side and also the left side glows, that means it now needs to decide itself whether to go right first or left first. Not only it's required that all the LEDs will glow, maybe it may happen that the right set, I mean one of the IR of the right set glows and also one of the IR of the left set glows. That moment it will have to take decision itself, in which direction it will move, be it right or left. That is up to the programmer or the user who will be using it. One can set the left turn as a prior requirement rather than right turn, or one can also set a right turn as a prior requirement rather than a left turn. This depends up to the user only. There is not much thing to tell about this. Just a tip from our side that you need to calibrate the IS sensors properly, or else it would result in disorders. So this is our circuit for the whole project. You can see I've just used the Arduino here, and the rest I've shown in blocks: the motor driver, the right motors, the left motors, even the 8 array IS sensor and the 9th one. Just make sure that you have to use two power sources for the IR, because the 9th IR is being attached separately and it is to be given a separate power from the Arduino source, or you may use some other source to give power. And nothing much more to say about the circuit. It's pretty simple as it can be seen out here. You can see that we have already built the line follower bot, and we are using an external power source. You can use an internal one by using the 9-volt batteries or the SMPS as per your choice. Now you can see that the bot is running well. It's well following the track, it's turning well, but one thing you can notice that it's not that much stable. It's wobbling a bit and speed is not that much as we can expect from a 500 RPM motor. In order to achieve that much speed or to get that much stability of the bot, we need to use the PID algorithm, and in that case the PID algorithm is demanded. We are going to understand the PID algorithm in the next video tutorial.